everyone. My name is GitEulerAngles, and I'm currently a freshman in college, or it's summer now, but I'm majoring in software engineering, and in this video, I wanted to show you a Mario project that I've been working on. I am making it using the Win32 API and in C, and if you don't know what that means, it's basically the equivalent of making a fire out of rubbing sticks together. And to people who know what I'm talking about, obviously C is not too terrible. I just needed it for a resume. However, it is 2 levels above binary, which I hope to never program in binary, and I hope to never program in the language above binary, which is assembly code. So this will be the lowest level that I go, hopefully. So the project starts off with me trying to learn the Win32 API, which is a challenge because I'm not only learning a new language, sort of, but I'm also learning a new API. So there I just got the window and the console to load, because the console will not load automatically either. Welcome to C. And create sprite, I also loaded it. I made a function such that it can load PNG images onto a screen. And I also figured out how to change the position of that image. And this all happened like over the course of several days. So essentially the lower level language to create some textures is to get the width and height of the texture, and then you want to allocate memory for the texture. The first thing I did in this image was rescaling it such that it would fit on the whole screen, but I will get into that later. So this function updates the handle for the window, which is just information on the screen at any given point. So essentially it takes in the width and the height of the image, and then we convert that data into raw bits. Then we see if the image needs to be flipped. I can get into that later. And then we create a compatible device context, and we select it so that it can be accessed from the Windows 32 API. And that was admittedly a pretty brief overview of what everything was happening, but essentially all this code allows me to do is just print PNG images onto the screen. And as for the flipping bits function that you saw earlier, this is for flipping the Mario coordinates for when the player decides to move left. You can see it working in action here. So the way this all works is you have to convert texture coordinates into coordinates as if the entire image was flipped, because it will be flipped when it is when the player is moving left. So essentially you multiply is flipped, which is 0 when it's not flipped, which makes this whole equation ordinary. But when it is flipped, then you multiply it by the width, and then you subtract the amount of frames, and you divide it by the amount of frames. Why? Because we start at 0 in computer science. So you're never actually reaching the end of a texture coordinate. If you're reaching the end of a texture coordinate, you are probably messing up. And the other thing that had to get done was animated sprites. So I had already animated Mario. Whenever Mario walks, his frame will go up by 1, and then it will go down by 1, which is essentially the entire animating process. So the next thing was to add physics into the game, which is split into 2 components. A, gravity, and B, whenever the player walks into a block, the block should subtract their position by the amount of overlap that the sprite has entered into the block, i.e. the block should push them out. And if anybody is creating a custom physics engine in the future, I have given a link in the description of the website that I found that was most useful in creating my own. So what I'm doing in Desmos here is I'm trying to calculate the amount of force that Mario has to have in order to jump over 5 blocks. So 0.1 is the acceleration of gravity in my game, and 10.1 is the velocity that Mario has to have initially in order to get over 500 pixels, i.e. 5 blocks. So testing to see that my hypothesis is correct, and it looks like it is. So here I just kind of fixed up the physics engine to make it so that everything is more seamless and smooth, and well, it looks like Mario now. So it was about time to add a new block in the game, which I chose to do a block that required some algorithm with neighboring tiles around it. And you're essentially seeing me edit the contents of the map via a text file, which is going to be a lot easier if people want to design a map. So these textures dynamically chose their coordinates in order to make it so that the map was more seamless and everything looked more natural. So this algorithm works by counting the amount of neighboring tiles of a given tile, but in binary. So 0 neighboring tiles would be 0, and 4 neighboring tiles would be 1 plus 2 plus 4 plus 8, or 2 to the power of 4 minus 1, which is 15. So as you can see here, the game is only a little bit laggy. Even to this day, I have no idea how I messed up this badly. I mean, it is literally just a pixel game, and we have 230 megabytes of RAM. But luckily, I think I have an idea of how to fix this. So after optimizing the code, I have officially restored all of the FPS in the game. So one of the things that still need to be developed was some sort of camera system, which for this recording I tested 3 of them out. The first one just follows the player around sort of statically. The camera position is just set to the player position. And the next one is sort of, it kind of reminds me of Animal Crossing. It sort of scrolls over to the next set of area whenever the player bumps into like, I think the position is like 80 or something. And the last one was something that I kind of settled on, and I think it more resembles the feeling of Mario than anything else that I can think of at the moment. So something we still need to develop is getting information from the text file and pushing it into a 10 by 10 array that we already have of sprites. So this is one of the most interesting errors that I've had in a while, but essentially I've mapped the array of sprites to the wrong area, so it's getting the incorrect block type. So this is what the camera system looks like when it is fixed, and as you can see, we have 90 block types that we can choose from now. Although technically we have an infinite amount, I just chose 90 by 90. So one more thing I want to do, and that's fix the physics system for the game, because currently Mario will sometimes glitch through blocks and he will appear to be in them even though he is not. But much more than this, he will not slide down walls. So in order to fix this, I am using Mario's last position in order to get the edge that he is colliding with, and then I just push him up by the amount of collision. So the very last thing that I want to do is to try and create running in the game, which should not be too terribly hard since we pretty much just add velocity.x instead of making it equal for whenever we press a key, for example. So I also made a background here, and it will scroll as the player moves left or right. And I also made it so that whenever we press space on our keyboard, Mario will just keep running for some reason. And he kind of looks like a spaceship right here. And I tried to plug into my code to ChatGPT, but I guess their servers were down or something because it was giving me really weird responses. So this is essentially the final product of the game. In the next video, I hope to cover some enemies and AI such as pathfinding or dynamic objects like mushrooms whenever Mario will hit a question block, and I don't know, maybe Goombas or something. Thank you for watching and getting this far, and I hope you have a very nice day.